Got a Doosan BC25S-5. There's a fault for F3, which is a drive-in inverter fault. What I'm going to do is show you how to test the MOSFETs that are inside the, or check the diode for these MOSFETs that are inside this controller. All right, and first thing you're going to do is put your meter in the diode function, and you're going to put your positive lead on the B minus, the negative polarity, and with your black lead, you're just going to touch each phase. And what you should see, since you're sending out a voltage when you're in the diode function, you should see a voltage drop across that diode. So that diode should absorb some of the voltage that is being sent out through your meter, and you should read the drop actually between the positive and negative side of the diode on your meter. That's what you're looking for. And typically you find anywhere from, on these systems, on these controllers, 400 to 600 millivolts. So going to touch this phase, got about 400 millivolts. Touch the V phase, got about 400 millivolts, and they should all be even. And now I'm going to touch my W phase, and you can see I'm showing 0 volts, meaning that all the voltage that is being sent out through my meter is basically being completely absorbed and is shorting out. So I have a short from this phase to the negative polarity. And just basically on the inside, this is what you're doing, all right? So you have 2 MOSFETs per phase. These are enhancement type MOSFETs, so they're normally open. And when you have these diodes these diodes are interrupting the polarity, either polarity, from going to the phase. The MOSFET actually has to turn on so that you can have a polarity at the U, V, or W. So in this instance, when this MOSFET turns on, you'll have a negative polarity. You'll have battery minus on this particular phase. All right, and if you turn on this MOSFET, you'll have battery positive going to this phase. All right, so going towards the arrow, that would be the positive side of the diode, and where it hits the wall, that would be the negative side. All right, so that's the reason why, if you're checking a diode as a one-way check valve, only allows it to go current to flow in one direction. That's why we're putting our positive lead on the main battery negative. All right, because the positive end of the diode is hooked up to battery negative. It's interrupting. It's not going to let because this is the positive side of the diode, it's not going to let, it would need a positive to go through here. So it's not going to let this negative get to this phase unless this MOSFET turns on, or in our instance, if this diode is shorted out, and you will have a polarity on this phase all the time. And you can do the same test on the opposite. So instead of you can put your battery negative on the positive polarity, and then with your battery positive, touch each phase, which I'll show you real quick. So all I'm going to do is take this bolt out. I'm just going to put it in the battery positive, and I'm going to put my negative lead on the battery positive, because we are on, even though we're on the positive feed into the controller, we're checking, we're on the negative side of the diode. And I'm just going to take my positive lead, and I'm basically going to read the same voltage drop. 397, 397, 398, and you can see this one's failed as well. All right. I hope that was helpful.